All right, so today we're diving into something that you're probably at least a little familiar with, React. But we're going beyond just the basics of building components and UIs, all that fun stuff. Today we're going to tackle a topic that I think is often overlooked, and that's data. Specifically, how do you manage data in these really complex React applications?
Yeah, that's a really important point. It's kind of like if you're building out a back-end system, you need a solid architecture in place, right? Well, large React applications, they really need that same kind of structured approach to data management.
Otherwise, you end up with data just flying all over the place.
Exactly. It's chaos, and that's when you start running into all sorts of problems and headaches.
Yeah, I'm already cringing just thinking about it. And that brings us to the topic for this deep dive, Flux. So, from your research that you've done, it seems like Flux kind of emerged as this response to the data management chaos that developers were facing, as their React applications started to grow larger and more complex.
Yeah, precisely. And coming from more a back-end background, you'll appreciate this. It's really about applying those architectural principles that you already know to the front-end world.
Okay, I like where this is going. So, before we get into the specifics of Flux, I think it's important to understand the context. We're talking about vanilla React here. So, what does that actually mean in terms of managing data? Like, what were the problems that Flux was trying to solve?
Right, so vanilla React, essentially it means that you're just relying on React's built-in mechanisms for data management. And those are, props and state. And, for simpler applications, this works fine. There's no problem.
Right.
But as the complexity grows, we say you're building something like a social media feed with posts and comments and likes and all that. Things can get really messy really fast.
Oh, I bet. I mean, with all that data flowing between all these different components, it sounds like a recipe for disaster.
It can be.
So, what were some of the specific issues that developers were running into?
So one of the most common headaches was something called prop drilling.
Prop drilling?
Yeah, imagine you have like 5 components nested within each other, and you need to update, let's say some user data in the deepest component.
Okay.
To get that data up to the top level, you end up passing it through each intermediary component, even if those components don't need that data. So it's kind of like, I don't know, like passing a hot potato or something, like a heavy box through a chain of people.
Okay.
It's just very inefficient, and it makes your code hard to read.
And is that where the whole spaghetti mess analogy comes in?
Exactly. It just becomes so tangled and hard to follow.
Yeah.
And another issue was this scattered state management.
Okay.
So imagine you have a user's profile information, like their username or whatever, scattered across multiple components.
Uh-huh.
If you need to update that username, now you have to hunt it down everywhere. And it just leads to inconsistencies and debugging nightmares.
So that sounds like a huge pain.
Oh yeah, it's awful.
So what about like tracking down where a change came from? Like why did a particular piece of data change?
Yeah, that's another big pain point. So imagine trying to figure out why a particular piece of data changed. Was it because of a user interaction?
Right.
A network response? A timer? Who knows? And without a clear structure for how data flows through your application, tracing that path, it just becomes incredibly difficult. It's like detective work, but in a maze, it's a nightmare.
Yeah, I can only imagine. At what you're describing it all starts to sound kind of like a really poorly designed back-end system.
Exactly. And just like with a backend, without that clear architecture, you run into problems with testing and maintenance.
Right.
Tweaking one component can have these really weird unintended consequences somewhere else in your app. And good luck trying to test components in isolation when their data is all tangled up with a bunch of other components.
So vanilla React at scale, it starts to look a lot like a back-end's gone wrong.
It really does.
Enter Flux, our architect for the front-end world. So from what I understand, the core principle of Flux is this concept of unidirectional data flow.
Right.
Can you break down what that actually means and why it's so important?
Sure. Think about like an assembly line in a factory, right?
Okay.
Each station has a very specific task, and the product, it moves in one direction step by step. That's unidirectional flow. It's predictable. It's organized. And Flux, it brings that same concept to data management in a React app.
All right, I like this analogy. So how does this assembly line translate to data in a React application?
Okay, so imagine a user, let's say they like a post.
Okay.
This triggers what we call an action, like a signal. It's basically saying, hey, a post was liked.
Okay.
And then this action, this little signal, it gets sent to what we call a dispatcher, which is basically like a central hub that broadcasts the action to all these things called stores.
So the stores are like the stations on our assembly line.
Exactly. Stores, they're the keepers of your application data, so think of them like specialized databases. Each one is responsible for managing a very specific domain of data. So you might have a store for posts, another one for comments, another one for user profiles, and so on.
Okay, that makes sense. So in our post-liked example, the dispatcher would broadcast that action to the post store.
You got it.
Okay.
So the post store would then process that action and update its data, maybe increment the count for that specific post. And then after it updates its data, the store emits a change event, like a notification, hey, my data has been updated.
And then this is where the views come in, right? Our React components. They're listening for those changes, right?
Exactly. Views, they subscribe to specific stores. So whenever they receive a change event from a store they're subscribed to, they know, okay, I need to fetch the updated data and re-render myself. So in this example, the view that's displaying the post, it would update to show that new, count.
Okay, so it's like an action genders a change, then the dispatcher broadcasts that change, the stores process it, and then the views react to it. It's like this beautiful, predictable cycle.
Exactly. And that predictable cycle, that's what makes Flux so powerful. There's no more data just flying around in some chaotic way. It's very structured and controlled.
This is really making sense now. I'm starting to see the light here.
Good.
But just to make sure I'm following along, can you just remind me of the 4 specific components of Flux?
Yeah, absolutely. So we've got actions, the dispatcher, stores, and views.
Okay, and just really quickly, just a brief overview. Actions are.
Actions, those are the triggers. So it's basically a message that says what happened.
Gotcha.
The dispatcher,
Uh-huh.
that's the central hub, like our air traffic controller, making sure everything is flowing in the right direction. It takes those actions and then broadcasts them to all of our stores.
Okay.
And then we have the stores.
Yeah.
Our little data keepers, they hold the application state. They contain the logic for how to update the data based on those actions they receive.
Right.
And then finally, views, which are our React components. They're what we actually see. They display the data, handle our user interactions, and they subscribe to those stores and update themselves when those stores change.
Okay, that was a great summary. So I think I have a pretty good grasp now on these 4 key players in Flux, but why unidirectional data flow? What makes that superior to the way you would do things in vanilla React? Okay, so we've laid out all the pieces of this Flux puzzle, right? We've got actions, we've got our dispatcher, we've got the stores, and we've got the views all working together in this beautiful unidirectional flow.
It is pretty elegant.
It is. So now I'm curious to understand, what are the actual benefits of this approach? What makes it better than just sticking with props and state in vanilla React?
Yeah, so one of the biggest advantages is predictability. With unidirectional data flow, you always know exactly where data changes are coming from and how those changes are going to ripple through the application. So it's kind of like having a roadmap for your data, which makes debugging way, way easier.
Okay, so no more playing detective in a maze of components.
Exactly, yeah. So let's say you encounter a bug. A user's profile info isn't updating correctly or something like that. With Flux, you can systematically trace that problem back to the source.
Okay.
Did the action get dispatched correctly? Did the store process that action as expected? Is the view updating properly based on the data from the store?
Right.
So it just becomes a much more methodical process, and you can eliminate a lot of the guesswork that's usually involved in debugging.
Yeah, I can see how that would be a huge time saver, especially when you're dealing with a really large code base.
Absolutely, yeah.
So what about testing? Does unidirectional data flow make testing any easier?
It really does, because Flux encourages this really clear separation of concerns. You can test each part of the system in isolation. So you can test your actions, just make sure that they are carrying the correct data. You can test your stores to make sure that they are updating their state properly, based on different actions. And then you can test your views knowing exactly what data they should be receiving from the stores.
So you're basically breaking this complex problem down into much smaller, more manageable pieces.
Yeah, exactly.
Okay, that makes a lot of sense. And I'm assuming that this also makes it easier for teams to work together on a project, right?
Definitely. When everybody understands the unidirectional data flow and everybody knows the roles of each component, it's so much easier to work on different parts of the application without, stepping on each other's toes.
Right.
It's like having this shared blueprint and a common language for how you're going to build the app.
Okay, yeah. Yeah.
Which, again, reduces miscommunication and the chance for errors.
This all sounds so beneficial. It's like bringing order to the chaos.
Right.
So I have to ask, if Flux is so great, why wasn't it just built into React from the very beginning?
Well, that's a really interesting question. And to really understand that, we need to look at how React itself has evolved over time. So in the early days of React, it was primarily focused on UI rendering. It was about revolutionizing how we build user interfaces, especially for these interactive dynamic web apps.
Right. I mean, the whole concept of components and the virtual DOM and efficient updates, like that was huge. That was a game changer for front-end development. But it sounds like initially the main focus was really on the V in MVC, like the view layer.
Exactly, yeah. And for smaller applications, React's built-in state management using, props and component state, it was totally sufficient.
Right.
It was elegant, it was intuitive. But as those applications started to grow in complexity, the limitations of this approach, they became pretty apparent. It's like trying to build a skyscraper using blueprints for a small house. It's just not going to work.
So it sounds like Flux emerged out of necessity, like as this response to the growing pains of React developers as they tackled these larger, more data-intensive applications.
Yeah, yeah, you got it. And it wasn't that, like, the creators of React just overlooked data management, right?
Right.
The need for a more structured approach like Flux, it just became way more obvious as the demands on these front-end applications they kept increasing.
It's like that saying, necessity is the mother of invention.
Exactly.
So where does Flux stand today, in this ever-evolving world of front-end development? Because my research mentions like all these other state management solutions and libraries. So has Flux been completely overshadowed?
Yeah, that's a great question. And it is true that the landscape has definitely evolved. While you might not see Flux being used directly in every project today, its core principles, they've had this really profound and lasting impact on how we approach data management in the front end.
So would you say that Flux was kind of like a pioneer, like it paved the way for all of these more modern state management libraries?
Oh, absolutely, yeah. Think about popular libraries like Redux or MobX, or even React-owned Context API. They all have either evolved from or they offer like alternative approaches to Flux's original pattern. But the fundamental ideas we've been talking about, unidirectional data flow, that single source of truth for your data, predictable updates, these are still at the heart of it all.
So even if someone isn't using Flux directly, understanding those principles is still super valuable.
Oh, absolutely, yeah. It gives you a mental model, like a way of thinking about data management that you can apply no matter what specific tools you end up using.
That's a really good point, and it's so interesting to me how these seemingly front-end concepts, they actually have implications that reach far beyond just building user interfaces.
Yeah, yeah, for sure.
It's really all about applying those solid architectural principles to manage complexity, whether you're building the back end of a system or a complex user interface.
Yeah, the underlying principles are the same.
I really love how this conversation has kind of bridged that gap between front-end and back-end development because it's so easy to get siloed into our own little areas of expertise, but ultimately we're all striving to achieve the same thing, to build these really robust, maintainable, and scalable applications.
Exactly, yeah. And understanding these fundamental principles of data management makes us all better developers, better collaborators, regardless of where we happen to specialize.
This deep dive into Flux has given me so much to think about. It's been really eye-opening. So before I wrap things up, was there anything in your research that particularly stood out to you? Any key takeaways or insights that we haven't really touched on yet?
You know what I find fascinating? It's how the need for something like Flux, it wasn't immediately obvious. It took developers really pushing React to its limits, building these massive applications before those like cracks started to show. Yeah, and I think it really highlights how a lot of innovation, it happens in response to these real-world challenges, right? You start with a tool that works well for certain problems, and then you start to push those boundaries and you discover new limitations, and, well, then you need new solutions. And Flux was a perfect example of that kind of evolutionary process.
And it's really amazing to me that even though, Flux itself may not be the go-to solution for every project today, those core principles, like, they're still so relevant.
Absolutely, yeah. Unidirectional data flow, having that single source of truth, predictable updates. I mean, those ideas they're fundamental to modern front-end architecture. They're like the bedrock for so many other state management libraries and patterns.
It's like thinking back to that house analogy, Flux provided the blueprint for a really strong foundation. And you can change the layout, you can change the decor, you can even add new rooms, but that foundation is still there and it keeps the whole structure stable and sound.
That's such a good way to put it, yeah. And that's why I think understanding Flux, even if you're not using it directly, it's so valuable. It gives you that mental model for how to think about data management, and you can apply that regardless of, the specific technologies you end up using.
It's kind of like learning the fundamentals of good writing.
Oh, yeah.
Those principles can be applied whether you're writing, a novel or a screenplay, even a technical document. The underlying concepts are still the same.
Exactly. And just like, good writing makes your ideas really clear and compelling, A good architecture makes your application more robust, easier to maintain, easier to scale. It's really about creating systems that aren't just functional, but they're elegant and easy to understand.
This has been a real eye-opener for me. Coming from more of a back-end background, I hadn't really grasped the complexities involved in managing data in these large front-end apps. It's easy to think of the front end as, just making things look pretty, but there's so much more to it than that.
Yeah, no, you're totally right. Modern front ends, they're getting more and more sophisticated all the time. They're handling a lot of data and a lot of logic right there on the client side. So a well-defined architecture, like the one that Flux provides, it becomes crucial for keeping things organized and making sure it's something you can actually manage.
I really love how this conversation has blurred the lines between front-end and back-end development.
Me too, yeah.
It's a good reminder that regardless of what we specialize in, we're all facing similar challenges and we can learn a lot from each other's approaches.
Absolutely, yeah. At the end of the day, it's all about applying those solid architectural principles to manage complexity, build better software, whether it's the front end or the back end or, somewhere between.
This deep dive into Flux has been incredibly insightful. So as we wrap things up, what would you say is the most important takeaway for our listeners today?
I'd say even if you never actually write a line of Flux code, the concepts that we've been talking about, they're really valuable. They offer like this blueprint for managing complexity in any system where data is flowing and changing.
So take these ideas with you. The importance of unidirectional data flow, having a centralized state, predictable updates. They might just spark some new insights and help you create even more elegant solutions in your own work. And on that note, we'll wrap up this episode of The Deep Dive. Until next time, keep exploring, keep learning, and keep those data flows flowing smoothly.